Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Alrighty, hi, I'm Tom Ball from the Research in Software Engineering Group, and we're pleased to have Professor Stephen Rice from Brown University. I've known Steve for many years. I think we met in '93 at the A debugging workshop, back in Sweden. Yeah, I think that's when we met first. And Steve has done work over many decades on really software engineering systems. I think there was Garden and wasn't it something like that? Yeah, Field, Garden, many different ways to bring together programming environments before there were really sort of things called IDEs, and really looking at the architecture and innovative ways to help programmers. And today he's going to, I think, tell us some interesting things that builds on all the work that he's been doing about creating user interfaces. So welcome back to Microsoft.
It's not really creating user interface, but we'll get to that.
Oh, okay.
So you feel free to interrupt, ask questions, the two of you who are here. I assume the others can't.
Oh, they actually can. I have to monitor the website. They can ask by chat.
Okay. Okay, so we start into this is something. You have code repositories out there. Olo claims to have 30 billion lines of code. I'm told GitHub is more. That's a lot of code. And these things keep growing exponentially. Last year, GitHub was around 18 billion lines. Now it's 30. Anything that you want to write these days at some level has already been written by somebody else. You just have to find it. Or something, if not exactly, something close to it has been. And the hypothesis is stealing code should be easier than writing it in the first place. However, given that, code search, which is how you access all this data, is not really used today. There are a variety of reasons for this. It doesn't return the right results. It's hard to determine whether what you get back is acceptable or useful or not. It's hard to determine what you get back, what it does, whether it does what you want it to do or not. It doesn't fit your existing framework. You're trying to put code in and find a function that will fit in your program. This code doesn't quite fit, doesn't fit your style. If you ever had to work with code in another style, it's really hard to do. And it's just too much work. There are a few exceptions on the smaller end, but we'll get to that. What I want to do, though, is use this. So let's go and do an example here. So let's put a few keywords in here. And now what we want to do is search. Now I can explain what's going on here. So here I have a sketch of a user interface, which I've grabbed off the internet and just duplicated here. And I want to find code that implements this.
So when you say sketch, so you really...
I really did Googled or user interface sketch, or I binged.
What is it?
It was a JPEG. As I said, I converted it. It's now an SVG.
Oh, okay.
Or it was a PNG or something.
Oh, okay.
I just took the picture and converted it.
Okay.
And I tell it to search and find the user interface, and it's found user interfaces that look something like it. That look something like it. And they actually are, because it gave it keyword address book, they probably are something like it. Okay, so we got that. Sorry about the delay. I should go back to the slideshow. Here we go. There's a lot of magic going on there.
Did it find the code that
It found code.
Okay. And
It ran the code.
To generate that.
And it ran the code to generate all those interfaces.
And it did some fuzzy image
And
comparison.
then it did the comparison, yeah. A lot of magic. You're getting the code from the repositories that does this, finding the user interfaces in that code, getting the code to compile and run. If you ever tried to get code from the repositories to compile and run, it's not easy. Matching the user interface that results to the picture I gave it, to the sketch. validating the user interfaces. We haven't gotten to that yet, but the user can go through and validate them. And then making the results useful, generating code that you actually want to use as a user interface code. There are a lot of things, and I want to show you how we do each of these. Now, getting the code should be simple. You know, we have all this code out there. There are existing search engines. Just go and use them. It's not as simple as that, though. The code search, if you remember using code search about 1990, using web search about 1990, it wasn't very fun. You know, you learned techniques that sort of worked. Well, code search engines are about at that level of primitivity. The best one I've found so far is Google web search addressing GitHub. But the Google API interface is not as good as the web interface. It returns different results. And they don't let you use the web interface from within a program. They turn that down. And Bing hasn't accessed GitHub yet. It hasn't indexed GitHub, so I can't try that. Keywords are a lousy interface to code. The code doesn't have keywords in it particularly. You have to manufacture them from comments, from variable names. And they're pretty random the way things go. And what's returned are files, not what you're looking for. So the result's not particularly easy to use. So you have to get through all that. So we can show what's going on here. I have another demo, if I can find it. This one's all set up. This is looking for ordinal numbers. I want to find a routine that, given the number 17, returns 17th, or given 3, returns 3rd. Except programmers probably don't know what ordinal numbers are, so they probably commented it incorrectly or called it incorrect in their code, and you never know what's going to happen. So here's code with like search for ordinal numbers, and trying to figure out what this does. This is actually GitHub here, access, and you're trying to figure out what this code does. Is
Nice name. You might want to choose your demos a little more carefully.
what's
It's very hard to figure out what this code does.
it doesn't look like much here is going to do what I want, but it's hard to say.
Okay, so this is just sort of not a surprise because you're just matching on the strings.
Right, and OLOs know better. So we, in order to do this type of search we want to do, we have to be able to do better search. Let's see what we get here. Browsing source repositories. Go to the next slide. Okay, so we went over this. Play from current slide. So that, you have lots of problems. It returns files. It's hard to browse and understand. It's hard to determine whether it's relevant, whether you want to use it or not. Who knows whether it's going to compile or not. And trying to figure out what it does is a lot of work. So what we did is we decided we had to do better than that, especially if we're going to use search all the time. So bring this up, and hopefully this goes. I don't have a circle going.
Good.
So what we're going to do is we're going to do search here, and what we did is we put up a use code bubbles essentially as a front end for code search. So we go and I think I pushed the search button.
I'm not sure.
I'm not sure.
Oh, yes, you got stuff coming.
Okay, so yeah, it goes out, and in this case, it's going out to OLO and GitHub, and using that and returning the search. Now I can use this in various ways. I can now look at the code and see what this does, and it doesn't. That ordinal trench byte. I don't know whether I want to use that. Doesn't look that relevant. But you can essentially look at things the way you normally look at code. So I can look at expand ordinal, see if that's at all relevant. And I can go and see what this routine does. And I can try figuring out what's going on here. Let's get rid of this. Go to the next one. Format double. That looks like it right. Format double. Format long. 0, 0. That looks like it might be working or close to what I want.
Fix me.
What?
It's got a nice comment in there, though, with an empty then branch.
Using JDK 1.2.
Yeah, I'm suspicious.
But you can again browse it. I can see if it's going to compile, test if it's going to compile fairly quickly. Say build it, and you see it. Most of it compiles. There's some stuff down here that doesn't compile because it's using a consumer. But the write routines I probably don't need. But I can do this type of investigation if I want to get more. Let's see. Let's look at one more here. Here's ordinal, get long, 2 ordinal of int. That looks like a good routine. It uses that. So bring that up.
Are we really your guinea pigs here?
For the talk?
I mean, this is the first time you're looking at this code? Or have you carefully selected these?
I have not particularly carefully.
Not that I'm accusing you of anything, Steve.
You're not a very good magician's assistant here.
Well, it started out looking pretty bad with the, yeah, okay.
But here,
This one's looking better. Right.
so this one looks like it works, except it uses a routine cardinal. And if you want that, that's probably also in the class. So what we can do here is go and tell it to expand this result, which will get the other packages in the class. And we'll go out and do a search for that, and then add them in.
So what happens if you really just want this one feature and you've got all this other code?
Well, I can now.
You want to just extract, in the end, you want to extract the stuff that you don't want to take a dependence on all this other code.
If I find a single routine I want, I can just go here and accept that particular result.
Okay.
And now I can go up here and this one, right? Yeah, save, which exports the accepted results.
Okay.
And just save and just export the code that I chose there.
Okay.
And it also does other things not all that well, but you'll notice there's a suggest button down here. And as I go and accept results, and as I go and delete results, it'll recompute a set of guess a set of words to do a new search with. So it's doing word analysis. It's sort of working. So I haven't rejected anything, but if I do a suggest here, it goes out, computes things, comes back, maybe. Maybe not. I haven't tried that. Yeah, I don't know what's running at the back end. Okay, so we can go back to the talk. We can now do search, and we actually use this to make get the user interface code to work. So talk. No, that's not talk. Where's the talk here? There's the talk. Okay, so we had that. What we did here, it turned out we did this in a week or 2 weeks, something like that, because we had code bubbles, and code bubbles is designed as a very plug-in interface. So you have Mint running, which is the message bus, and you have code bubbles there, and the message bus talks to Eclipse at the back end with a little plugin in Eclipse, and then you have various active things, and then code bubbles has all these different plugins for editing, code editing, text editing, debugging, and so forth. Now we started with that for Rebus. And what we did is we just removed all the stuff that was Eclipse specific, including things like debugging, which you're not going to do in search, and educational extensions in the programmer's notebook. And then we added a backend, Rebase, to replace Eclipse. And that's it. That made it work. Now, Rebase, we had to work on this backend. And it's fairly simple as well. It talks to the message bus. It has a command interface, which has various search commands. We have plugins for the different search engines, so you can add a new search backend in a matter of an hour or so. And so that was an hour for grep code, which is the last one we added. It has this code to handle word bags to deal with suggest. It has an editing interface to let you edit the file, so I can actually edit the code there, and then try compiling it and seeing what happens as I edit to make it compile. A project interface has file, and then there's a plugin for Java backend, so you can plug in whatever language semantics you want to make it work search over particular languages, because it has to be able to compile and understand the code. So that was the first problem we had to deal with in user interface search, is getting the code for the user interface. So assuming we can do that, we still have to find the user interfaces in the code, get the code to compile, and so on and so forth. Now, all of that, we were convinced we could do. And the way we were convinced of that is we had another search tool we did before. This is here, and that's here. And this basically is what we're searching for is ordinal number and say third, just to make it a little more specific. And we told it we have a signature, which is string of ord, and a function taking and returning a string. And we're giving it a test case. In this case, we say 17 should return 17th. And that's all we're telling it. And we want this to find code that actually does that. Now this is going off, and it's going to, in this case, GitHub, and finding code that matches ordinal number and third, taking every function in there, thinking that might be a particular solution, and seeing if that solution works or not, and making it compile first, then testing it against your test cases, and whatever comes back, it'll, if it passes the test cases, it's going to accept it and show it. Now there's a lot going on to make it all do that.
You're using VMs to protect yourself from malicious code, I hope.
Well, no, I'm running, well, it's run as a separate process.
Okay, it can still go to the file system.
And two, it's running with the Java security measures.
Okay,
So I
as an applet sort of?
Yeah, sort of thing. I could set whatever level of security I want. So I can set file security to allow whatever I want to allow. And the default is don't let it write files.
Okay.
Question, how does the third help the search?
How does the?
You search for ordinal number third, right? Are you looking at comments or?
Well, I want something. I'm thinking that if it's going to convert things like 17th to 17th, it has to convert 3 to third, and third's a word that's not going to appear that many other times. So I'm trying to restrict the search in some way.
And you expect the string third to appear in the code somewhere?
Well, if it's going to output third, yeah, I expect that's going to be a hard thing for the code to have, to generate without having the string there.
Yeah, right. The special cases. So you're saying I know some special cases that are probably going to.
I could do it without, and actually without in GitHub it works. Without in Olo it doesn't work. It just takes longer because it has to try a lot more things. And I wanted this to finish. So here, and we can. Here you see you get. Here's one piece of code that does it. And yeah, it's sort of reasonable. Here's another piece of code.
That looks like generated code.
I think it's just you typed in. Well, it just reformatted everything. I told it to reformat. You want to use it, it basically will reformat it into whatever style you want, and I told it to reformat it in my style. So that's getting the output. And here's another case. This is actually similar to the previous case, same code. Probably minor change. And this is different code. But you know, the code exists. It's out there, and you should be able to use it. And I can just cut and paste this and stick it in my routine. And having some sense it'll work. I can do additional test cases if I want. It's now in my format, and it's useful.
You go find the licenses and pop those up too, so you know what you're getting.
Okay. Where's? Okay, the license should be here. Why doesn't it have it?
Okay, just trying to make trouble. But,
No,
seriously.
it does have the license.
Okay, somewhere.
If it had one, it should have a button over here to show what the license is. It does extract the license from the code.
Okay.
Sticks in a database. Now maybe, as you said, a distributed system depends on lots of machines. The database server might not be working at this point. And then it depends on the database server to look up the license based on the license ID.
Right.
Actually, since the system that's running here has been running for 3 or 4 weeks, it's probable that the database server has at some point died, and it hasn't necessarily recovered from that. I'll try fixing that, though. But yeah, it should have the license, and we do extract the license. Okay. So we had to get what we found in doing this, making that magic work, is you had to get the code from the repository, find the candidate methods, so find particular methods that might convert a string to an int to a string, get the code to compile and run, again, checking the resultant code using users' test cases, validating the code, making sure it all works, and making the results useful. Now this is a lot like what we want to do to make user interface search work. Basically the same thing. And what we're trying to do here is take some set of specifications, whether they're test cases or whether they're a user interface sketch, and essentially generate a program from that using a black box automatic programmer. In code search, you're doing something similar. You're taking specifications, which happen to be keywords, usually, going into a black box search engine, and you're getting code back. Well, actually, what you do is you get that code back, and then you do a lot of program analysis on your own and program editing, and try making it do what you want to do, figure out which code might work the way you want it to, and take that code, and eventually you get a program. What we tried doing in S6 is take the solutions you get from the code search tool, code search engine, and do the type of transforms on those that you as a programmer would do yourself. To make it compile, to make it run, to figure out what actually would be useful. We generate lots of more solutions. We again do transformations on those solutions. We eventually validate it and generate the program. And that's basically what S6 does. So we think about taking specifications, which in this case are the signature, the test cases, and the keywords, feeding it into S6 and generating a program from that. Now the way this works is it first uses keyword search to go out to the search engine. That generates a set of initial solutions. When we're looking for a method, we say each method in any of the files that's returned is a candidate solution. And we generate all the candidate solutions. Now we apply transformations. Transformations come in a whole bunch of varieties. There's some simple ones, like change the name of this method to be the name the user specified. Very simple transformation, except you have to change any recursive calls and things like that. Or some are a little more complex. It has an extra parameter here. Let's remove that parameter and insert an assignment statement. So it has a Boolean whether to return upper or lower case. We'll try true and false and see whether each one of those works. And then there are even more complex solutions. So find a line in the code that computes a value of the return type, do a backward slice until the only free variables are values of the input types, and extract that code from the function. This is useful because they often find code that does multiple things at once, and you only want one of those things done, so we're essentially splitting the function up automatically. But we have about 40 different transformations we're using, and each time you do one, you generate a new solution, and you just keep doing this until you can't apply any more transformations to generate new solutions.
So how often does this really work? It seems awfully complicated, and I mean, do you have people using it? I mean,
I use it.
Yeah.
It's on the web. People try it.
But really, I mean, have you done a study or something to see?
I've taken the original paper. I had a number of test cases, 10, 15 test cases,
Mm-hmm.
and
so what sort of things? I mean, were these?
I'd have to look at the original paper.
Okay.
But they range the gamut from little simple string manipulation functions to robots.txt.
Right.
Finding something that computes robot, tells you whether there's a robots.txt on this web page.
Okay.
I did English stemming recently, this way. English stemming. Something that would stem English words,
Yeah.
or remove plurals at least. But it depends. There are two things it depends on.
Okay.
One is the keywords, which given now we have the rebus stuff there, so you can do a better exploration and figure out the right set of keywords to add. Makes that easier. And the second is a set of transformations, and we keep expanding that set of transformations.
I don't understand the transformations. So you said like slicing, for example? I mean,
Well, we basically find the line that computes a value of the return type and do a backward slice until the only free variables are the input types. Essentially identifying code within a function that does what you want it to do, potentially.
But you only specify keywords, so how do you have to specify some sort of interface to know that?
Well, we also, there were three things to the specification.
Okay.
Keywords,
Right.
the signature, and the test case.
Okay, so the signature is going to help you a lot, but you might have functions that like have all sorts of genericity, have extra out parameters, in parameters.
We have transformations that remove extra parameters.
I see.
We have transformations that reorder parameters.
I see, this is getting back to my original question is, how do you extract? So the transforms are about extracting sort of just the code that you need.
And making it compile.
Right. And then the tests are your validation.
Right. It works a surprising amount of the time.
Okay. So
Especially
this
as
we can just try?
yeah.
Okay, all right.
We have to do dependency analysis because you saw in the ordinal number case there were the function is one thing, but it used some static variables, it used helper functions, and that's what this does. It finds all the other things that are needed from that other than the original solution. We generate test solutions. We actually run JUnit tests on all these things. That's what takes the most time. We actually analyze the failure reason for these solutions. And we can do additional transformations. So if it returns 17, where 17 is capitalized, or the S is or the whole thing's in caps, and we want it all lowercase, we have transformations that can deal with that. We have transformations that can deal with off by K errors, things like that. You can go generate new solutions. They get tested. Eventually, you get some that pass, hopefully. We can do formatting and then return it back to the user. So this magic can be used for user interface search. We looked at user interface search as a problem along the lines of what we were doing here with S6. You're not old enough to know what S6 is a play on words of, right?
No, I don't understand it.
Okay. Bell Labs had a system called L6.
L6?
Bell Labs Low Level Linked List Language.
Oh.
It was the first graphical, it was essentially, it generated videos from the language.
Oh.
It was great, it was sort of early Lisp.
Okay.
It's a good name. The issues, here we have to get the initial files. Again, we're going to do, we have things for that. We have to get the candidate solutions. Solutions differ. We don't have methods, we have user interfaces instead of that. We have some problems with files. We have to find appropriate transformations because the transformations used in S6 may not be appropriate for user interfaces, or there might be additional transformations which are appropriate for user interfaces. We have to find a way of testing the solutions. We don't have test cases anymore, we just have this picture. And we have to present the solutions to the user, and presenting code isn't exactly what you want to do here. So we had S6. What we did here is we removed parts of S6. We no longer needed the dependency analysis. And we didn't want to look at failed transformations and failed solutions. And then we just added something to show the user, to validate. So other than that, it's the same architecture. It's actually using S6 in the back end. So finding user interfaces in the code, this is what we need to do. So initial files, use keywords as before. This is going to work, right? We're going to return the keyword files. How many people write user interfaces that fit in one file? Not that many. There are a few out there, and we found them. But if you want to have a broader selection of user interfaces, people are going to write their auxiliary files. They're going to write their own implementation of the list widget that they want some additional features for. They're not going to necessarily nest it. They're going to have a user interface class they're going to use, or a user interface package they're going to use for the rest of their system. And you have to deal with all this. So interfaces tend to span multiple files. Depends how they were written and that. So what we did is we extended S6 to handle package and system search. So instead of looking for files, you can say look for everything in this package, and it'll essentially find the file that comes back from the keyword search, then expand that to include everything in the package, just like we did in Rebus to expand it. You can expand it a second time and get all the related packages in there. You can do that in Rebus too. Takes a little longer. But this generates a single source, and then we just do transformations. It has multiple classes in it. Probably is not legal Java to compile. but we can it's close, and we can eventually generate real classes from that and actually compile it. And we added a lot of new transformations, or a few new transformations, to split classes up, to extract inner classes into outer classes, make classes static where need be.
Well, there's going to be. Are you relying on any like model view controller split, or are you going to actually like bring data of the application over? I mean, if you want to show the user interface, then you have to generally populate it with something.
Yeah,
Okay.
we'll get to that.
Okay.
And that's transformations, yeah.
So just a quick technical question. So one thing that can happen with UIs due to things like localizing text and things like that is sometimes things can get externalized outside the code.
Yeah, we deal with that.
Okay.
So we first have to identify, I'll get, that's in the swing transformations here. So we do transformations, that's what S6 does. So we added transformations to, well, first we had to identify potential solutions, we identify potential interfaces. So any class that implements a component, we say the constructor for this class can be a potential user interface. Any method, a non-private method in a class that returns something of type component, we say this can be a potential user interface. Now we have a potential solutions, we have to set it up so we can actually use it. So we set it up to have a separate class which effectively calls the constructor, or calls the constructor and then calls the method, and then returns that user interface. So we have a transformation that does that. Now we have to handle all these weird cases of swing and internationalization and everything else that goes along with that. And we added these swing transformations. And they effectively do that. They look at all the calls to the swing code. And if anything is undefined in those calls, or if they are calling the resource manager at any point, we replace that with, don't remove the call, but replace it with something with a fixed string, or a new string each time, S6 underscore temp something something, some unique string. We replace all resource manager calls. We have our own resource manager we can substitute in. You have problems in that they'll use outside models, tree models or list models for your particular application. That's usually not in the same class. You may or may not want that to copy their whole model. So we'll replace it with our own model. So we have a transformation which removes their model and substitutes our model. We have transformations that if they're using some class we don't have a library, but it looks the same as a swing class, we'll replace it with the swing class. But there are lots of different transformations that try to make it so that it'll compile and still generate a reasonable user interface. We have transformations to simplify things. We are taking this code, which is not just the user interface. We want just the user interface back. So we want to throw away everything that isn't related to the user interface. So we'll go and do a dependency analysis, and effectively any code that's not used or that can't be reached directly we'll throw away. And then we'll throw away some other code too if it's private methods and things like that. We'll make sure it compiles. We'll make sure we remove anything that's other than swing calls that looks undefined. And eventually we'll come up with code which is just the user interface. And we also do all the standard ones. And has a good chance of compiling. Now we need to test it. The code has to run. And what we do is we actually run the code. We actually build the user interface from the code. That generates a widget. We basically crawl that widget, looking at the hierarchy imposed by that widget, and compare what the what that widget is to what the user's diagram looked like. And then we order the results on how we match. Now we have to do this. We have to understand the user sketch, and we have to develop a matching algorithm. The sketches, well, we didn't want to start with arbitrary sketches, although I'm told in another 2 weeks we can start with arbitrary sketches because we have something which translates an arbitrary sketch into an SVG diagram suitable for our use. So we're working on that. But then we essentially take an SVG diagram, which is a structured graphics. You can do almost anything there. But it's great because there are lots of tools that generate SVGs or let you do that, either web tools, web interfaces, or Inkscape and things like that. And then we have classifiers, which we run over the SVG to try figuring out what each component of the SVG is. Some of them group multiple items. They assign properties to the items. So here's a simple example. It's a login panel, login dialog. We first identify all the SVG elements here. So you have one for that text element there, text element here, a rectangle here with some a text element in it. A little box there, remember me, text there, and a circle around it, and then the whole thing is in an element. Okay. And now we basically identify what these things are. So we say that's a text field. And we say, it's probably going to be a text field because it's a box and it's shaded. That's how the user would typically shade it, or a big outline around it. That's how you typically represent it. This is a text field as well, but because it has stars there, we're going to guess that it's a password field. These are labeled. That's fairly easy. They're not inside a box or anything. They're just text. These two go together because they're adjacent to one another, and this is sort of a box of some sort next to a piece of text. This is probably a radio or a toggle button of some sort. And you're not going to be able to differentiate them from a sketch. The user's going to make them look the same way. This is, again, text inside a box, and it's either a text field, or in this case, because the box is round, it's probably not a text field, it's probably a button. So we'll do that type of analysis on that. And these are the properties we're looking for. We're looking for, is it an input area or not? Is it a button or not? Could they represent a table, a box with lines, vertical and horizontal lines, a list, a choice thing where you have a box that has a down arrow on the right, so you can choose multiple things there. Plain text, whether it's a symbol, some little icon the user tried to draw, whether it's a line, whether it's something used only for grouping, it doesn't have any other effect. Options, multi-line text versus single-line text. Scroll bars we detect. We have a classifier that looks for those. Numeric fields, if you only have numbers, we can detect that. Sliders, icons. We look for all these different types of things. So, example, components only containing text. Combo boxes, as I said, there's a box with a symbol to the right. Those are examples.
So Steve, you're assuming somebody's done the conversion of a picture to SVG.
Yeah.
So you know what lines are.
Right.
SVG is telling you this thing's a box.
Right.
Right.
And that's what I have a student working on.
Okay, so you have this decomposition of the SVG. The problem of taking just an arbitrary set of pixels, array of pixels, and mapping it to
The SVG. I've separated that.
Right, but once you have the SVG, you still have quite a bit of noise. So what are your classifiers? How are your classifiers dealing with just the different ways a scroll bar may appear and all of that?
They're basically hand-coded and trying to look at all different possibilities. So it's for a scroll bar, I think it looks for a rectangular region, which is either long and narrow or tall and narrow. One of those. And it has something at the top and bottom, and maybe something in the middle. And so a little symbol, you typically will put an up arrow or down arrow.
But these things are robust to scale, translation? I mean, the classifiers are robust to many transformations that might be done? Right.
Okay. I've tried to make them that way.
Do you have data on sort of how good they are?
I'll show you the test cases I've done. And, we have lots of different ones that go there. We now get a hierarchical set of items. You have nesting here. Each item has a position, has a size. Each has properties, which are these things we can assign to it. We now map each of these items into a candidate by saying this item can be one of these types of widgets. This is the only place we're Swing specific. If you wanted to use Android or some other toolkit, you just use a different mapping here. So we'll say this can be a text field or a text region or whatever it can be. We also look at and determine relative positioning between these components. So if this is close enough, we'll say this is above this one, this is to the left of this one, this is to the right of this one. If it's nested, we can say it's at the top of its nesting thing or at the bottom of its nest, of its parent. And we're generating a hierarchical component specification, which looks something like this for the example we had. So you had the thing, here's a component, that's the top, it says it's a panel. Then you have a component which is a label, which is the username there. You have a component which is a text thing, that's this thing here, which is left of the label, which the label is on the left of, and so on. So this is what we're trying to match against, effectively. And that's the output of our pre-scan. Now we have to compare the hierarchy. We have to compare the actual widget to this hierarchy. So we get the widget hierarchy through introspection. We find all possible mappings, or in theory we'll find all possible mappings between the actual components in the widget and the components in the hierarchical specification. It turns out we are going to stop at some point because there can be an exponential number of these. If you have 20 text fields, you have 2 to the 20th different matchings. You don't want to look at all of them, or if there are 32 text fields, you're never going to finish. But we'll find some set of matchings there. And then we have the matching has to obey the hierarchy. So it says this is nested in. We have to be nested. The type constraints are obeyed. Most of the abstract widgets are mapped, and there are not too many extra components. You know, we're a little fuzzy here. And there are reasons for being fuzzy, and I'll get to them. Then we score the mappings. So we'll look, and you have a diagram there. We'll look at the width and height of the actual widget. And if it's within 100, we'll give you points for that. We'll give you credit for being width and credit for the height. If it's strings, we're going to do a string difference on the text. So the strings are the same. We're going to give you quite a few points for that. We'll look at the, you have relative positioning, we'll look at the relative positioning between the two. And if you're within 50 pixels, we'll give you points for that. If you have extra components, we'll take off points. Or if you have missing components, we're going to take off points. So we're going to penalize and we're going to add. And we essentially come up with a mapping.
So the scores, it seems
Don't
like
use for ranking things.
Right, exactly. So I would think a good property you would want the scoring system to have would be something like you'd want the differences in scores to be sort of proportional to the amount of engineering effort it would take to overcome the gap. So for example, things being kind of in the wrong pixel order, like something's supposed to be above, but it's really below. I mean, that's a super quick fix, right? I mean, that's no big deal for tweaking the code. But for example, if something is supposed to have a password box and it doesn't have it, obviously it takes a big engineering effort to do that.
The larger penalty from extra components and missing components.
I don't know. I guess my question is
Missing is the
come
largest.
up with the scoring?
Heuristically, experimentation.
Okay.
The scoring, but you get the good match is going to be at the top, and you don't care about the things towards the bottom anyway.
Right.
To validate the results, I'm not going to do the validation. We're going to show the results to the user, and you saw that at the original screen. And we have the ability to return the code, so we can go back to where we were. Maybe. I want that later on. This one. Yeah, there are our results. What we can do here is we can click on any of those results, and we actually get the, it lets us run that immediately. We can see what it looks like. We can play with it. We can see all the events that are generated. We can see what happens if it lets us to change, this one doesn't let you change the size. But if it did let you change the size, we could play with that. Here's another one. I don't know why it doesn't let you change the size on this. But you can interact with it and see if it's acceptable. The ones you like, you can accept here, or you can accept them here or reject them. And these are the same.
Can you show the original picture? Can you do these side by side, sort of like?
Yeah, I just have to find it here.
Yeah.
I didn't get rid of it. There it
Oh,
is.
there it is. Okay. So it sort of had a big text area on the left. All of those sort of do, except for the bottom. One's at the bottom.
Right.
And then it's got some fields on the right with text labels.
No.
Uh-huh.
This is missing in all of them. Some label at the top is missing in all of them, but yeah, they're reasonably close. And you know, something like this, you know, it has name, address, you know, whatnot. But once you accept whatever you want, you can now say get the code. And it returns the code for your accepted things. What we haven't done is made the code something you want to use yet, because most of the code that's out there that generates user interfaces you don't want to touch with a 10-foot pole. But that's another set of transformations we have to work on. We are. But you can actually get the code that implements that interface. You can do a few other things. We let you do some minor editing of the user interface as well. So I made it, but I can change the labels to say what I want and rearrange, make things visible or not visible as I go. And if the code is interactive, you can actually interact with it. So if it has buttons, tabs, and they show you different fields, the interaction will show you that.
So I have a question.
Yeah.
So user interfaces seem like a particularly hard example, right? Because there's sort of, you have to stitch together multiple levels of things. You have to understand the user's intent in terms of what just the image processing aspect of it and so on, and then down all the way to the code comprehension stuff. I mean, do we have code search working well for non-user interface related tasks? Can you search effectively for I don't know, something?
No, S6 will do it fine if you have test cases. If you don't have test cases, I don't know why.
Yeah, with test cases. I mean,
with test cases, yeah, S6 tends to work.
And
If you can find the right keywords.
Have people been using that independently
I have.
of the user interface?
I haven't made it that public, but I have been using it. Whenever I start writing code where I think somebody's, I don't feel like writing this routine, whether it's doing some string manipulation, whether it's doing English stemming, robots.txt, or even simple things,
So the test cases,
command line parsing, for example.
the test cases that you provide are usually textual. I mean, can I describe, I want a red-black tree implementation that's got some tweak on it? How would you specify something
Well,
like that?
it's hard to do a test for a red-black tree because any tree implementation should pass all your tests. Now, you could do keyword search with red-black and then see if you have a tree implementation in there, and that might give you what you want. Or you can give it a very complex case and see which ones have the proper timing.
It's hard to do a test case from the looking at it just functionally from the outside.
Right.
But if you are able to say, I want a tree data structure, I want it to look like this, and I want it.
Okay. S6 will handle that. It's not easy to use. It has a notion of user context. If you actually run it from within code bubbles, you can write your own test cases, and there are transformations where it'll use your classes, and it'll take code that has some other class there and map that class to use your class. So if you have your own node, whatever you want to implement there for that, it'll try transformations which do that mapping for you.
So do you feel like the basic code search functionality in S6 is, good enough, and you feel like that's almost a solved problem, and that's why you're exploring this like one more level on top of it, which
well, it's a solved problem. I think it's a solved problem. Given you probably need another 2 dozen transformations to handle everything, to do some of the mappings there, especially on the context stuff. The context mappings we have are sort of primitive. 2, you need a lot more CPU power. I'm right now running this on my desktop machine. Now my desktop machine has 16 cores and 64 gig, so it's not the trivial machine, but it could actually run in the cluster very easily. And you need to have the right keywords to begin with. Keyword search is really bad. And you need to be able to do test cases, and that only works, as you noted, in a smaller set of things. But I think for those cases, yes, we've basically shown that if you can find the code, we can do the transformations and make it useful. If the code exists in the repository. If you try doing something really complex, the code might not exist in the repository. In that case, there's not much we can do. This is why we aim for guided code search, where you do it piece by piece, and the pieces are there. But user interfaces are one of the things, trying to go beyond test cases. What can you specify? And this is one. Another one I want to work on this summer is architectures, where I can specify it with a UML diagram, and then do a search for something that implements that architecture. Okay. So this time I'll start from the current slide. So we did that. We did that. So to validate this, we did a web search. I don't know if we used Bing or Google, one of those, for user interface sketch, and we basically found all these things out there. We converted them to SVG just by taking the picture and making it an SVG diagram that looked basically the same. And then we had to figure out keywords. And the first time through, without the rebus there, half of them failed because we didn't have the right keywords. After we could go and find the right keywords, we could make all of these things so we could actually find the corresponding interfaces. And you can see logins should be fairly easy. And it had lots of solutions that it had to look at. And it actually found 45. But you can see all of these, it found them. The stars here mean there were other solutions that didn't try, that had stored up. And basically, if it finds some, it only looks at a limited number at a time. So there are potentially more solutions there. And we didn't look at more than about 5,000 solutions on any of these. There are test cases when we're looking at things at not the file level, but we expand it to package or system, where we look at 50,000 solutions or something along that ilk, and it takes hours rather than minutes to do. But we did find solutions for all of those problems.
I just have a philosophical question. I mean, there's been a huge amount invested in designers for GUIs, where people draw the things they want and then you get the code. So if you go this route, you get a piece of code that's sort of close to what you want, but are you really better off in the end this way than starting with what Visual Studio provides and doing the design? I mean, I'm very suspicious, right?
Yeah,
you're getting something
I understand.
Not really what you want, and it's got a bunch of underlying code that
you may or may not want to use it. There might be easier, but if you try using any of those toolkits, you find that it's a lot of work to make it so that you have the right hierarchy there. It grows, the window grows correctly. You have the right interactions between all the things.
You're saying when I get the code,
the code potentially includes all that.
So somebody else has gone through the hard part of really making it work well together. So I can drag and drop the widgets. But then I still have a lot more work.
You still have a lot more work.
Sort of this,
and it may or may not scale when you do the right thing when you resize the window.
Yeah. Okay.
That's one argument I can give. Okay. Second argument I can give is that I'm going to do UI development. Here's my initial sketch. I started with the initial sketch for the pizza program. I relaxed it a little, and I got all these different sketches, which are different user interfaces for restaurant ordering, basically.
Right.
So I can use it for exploration. So I can take my initial sketch, and most of these sketches aren't your really final interface.
Right.
Even the address book, I didn't have separate name and surname. Seeing the examples there, maybe I should be doing that. Maybe there are other fields I'm missing.
I've never designed a UI before. I mean, this is valuable just to see what people have done. Yeah.
So that's one of the things. It seemed that's one of the reasons we make the scoring fairly lax.
Okay.
Not only because we want to find something, but also because you want to have the ability to find alternative interfaces. And that's a valid use in and of itself. So here's a nice one. It doesn't look necessarily like the original, but it has most of the capability, and it actually does move the total there. There's interactive code for that. And there's another use. We're able to generate an image. So going back to our example here, this one, let's remove everything. That's what the big red button does. And do login, J checkbox, J password on both, and do a search. We should remove all the windows here. Now we can take something here, take this, and say, show the user interfaces. So not only can we search the code, but we can now tell it to find the user interfaces in this code. It will go essentially using the technology that we developed here to show the user interfaces that can be generated from that code. You can see the different transformations and to get different labels, but you can do this for anything to see what the code looks like. Okay. So, go back here, play from current slide. So we can use that. Current status, S6, as I said, is a functional website. Rebus is actually distributed as part of Code Bubbles. I don't tell anybody, but if you just run Code Bubbles minus Rebus, you get that. Swiss, the user interface stuff is under development. The code is actually out there, not necessarily the current code, but it's there. And we have a number of things to do yet, which I mentioned. We're working on going to direct manipulation interfaces rather than just static ones. I don't know how to do that. There are not that many Java ones out there that do direct manipulation, and these don't do it cleanly. And then we're looking at, as I said, frameworks. Our eventual goal is to take this little toy here and write a simulator for it with the user interface and the physics engine and everything else without writing any code ourselves, doing it all via code search. So we want to do start with specs and essentially do program creation from code search. We're also looking at bug fixing via code search. We do a lot of other things. That.
Great.
So, I didn't want to take more time.
Thank you, Steve. Simulation